You'll recall in Proposition 4, we proved that if we have two triangles where the respective sides are equal in a side angle side fashion, then the triangles themselves are equal. And now in Proposition 8, we're going to prove that if we have two triangles in which the sides are equal in a side fashion, all the sides match up respectively, then the triangles are the same. So hence, we're going to prove the side theorem in more modern terms. So let's turn to the text. If two triangles have the two sides equal to two sides respectively, and have also the base equal to the base, they will also have the angles equal, which are contained by the equal straight lines. So let's set this up. Let ABC and DEF be two triangles having the two sides AB, AC equal to the two sides DE, DF respectively, namely AB to DE. So let's draw that in. We've got AB, that's going to be equal to DE, and we'll mark their equality like this. AC to DF, so we'll put AC over here. That's going to be equal to DF. Mark their equality as such. And the bases are the same. BC is going to be equal to EF. And I'll mark it like this with the triple dash. Euclid claims that the angle BAC is also equal to the angle EDF. So he claims that this angle is the same as this. And now we're going to go ahead and prove that. So how do we prove this? He says, for if the triangle ABC be applied to the triangle DEF, and if the point B be placed on the point E, and the straight line BC on EF, so what's going on here? We're going to imagine picking up this point B and placing it right on top of E, and recall that BC is equal to EF, that's a given. He claims that the point C will also coincide with F, so that this point C, when you do this, is going to coincide with F, because we have the equality of BC and EF. They can't fail to coincide. Then BC coinciding with EF, so these bases are going to coincide, he claims. BA and AC will also coincide with ED and DF. So he says that when you do this, you place B on E, the bases will coincide, and he claims that BA is going to coincide with DE, and AC is going to coincide with DF. And let's consider the case where they don't. Let's consider the possibility that they don't coincide. He says, for if the base BC coincides with the base EF, so these bases coincide, and the sides BA and AC do not coincide with ED and DF, but fall beside them as EG and GF. So what's going on here is when you place B upon E, if something like this happens, they fall beside them, like so. We call this side G. Then this contradicts proposition number 7, where we showed that this construction is absurd. It's impossible. Euclid says, then, given two straight lines constructed on a straight line from its extremities and meeting in a point, there will have been constructed on the same straight line from its extremities and on the same side of it two other straight lines meeting in another point and equal to the former two respectively, namely each to that which has the same extremity with it. But they cannot be so constructed, as the previous proposition has proved. In our conclusion, therefore, it is not possible that if the base BC be applied to the base EF, the sides BA and AC, so once again we have BA and AC, should not coincide with ED and DF. Therefore, they will coincide. And from this, we draw the conclusion that the angle BAC is equal to EDF, because things which coincide are equal by common notion number 4. And we can draw the further conclusions, although Euclid doesn't state them, that ABC is equal to DEF, and lastly that ACB, this angle here, is going to be equal to DFE. Therefore, we may infer from the side-side-side equality of two triangles that the respective angles are also equal.